Yeah. Hello and good evening, everyone. Welcome to gatesmashers. Welcome to my class. Today is the closing session of EMF. Today's major topic will be capacitors and inductors. Video, audio clear है क्या? Yes, hi Mamta. Please confirm video and audio. Is it clear? Someone please confirm the video and audio. Today's topic is capacitors and inductors. Myself, I am GC Reddy, having 14 plus years of experience teaching, guiding, and mentoring students preparing for different competitive exams. Areas of expertise: EMFT and communications. So we'll go for capacitors and inductors. So we'll see some basic formulas. If you take a parallel plate capacitor, what is the formula for the parallel plate capacitor? The capacitance of a parallel plate capacitor, C, is epsilon A by D. Where D is the distance between the plates, A is the area of each plate, epsilon naught is the permittivity of the medium. Here epsilon naught means if I am assuming that permittivity is free space. It's for a parallel plate capacitor. Similarly, when you consider a cylinder, the inductance is given by n square mu naught A by D. The inductance is given by n square mu naught A by D. Or you call simply a solenoid. You call it as a, for a solenoid. For a solenoid. Can anyone tell me why it is n square? Why it is n square? For a solenoid, why it is n squared here? What is inductance formula? Flux linkage by current. What is flux linkage? N psi m by I. What is flux linkage? N psi m by I. What is psi m? Surface integral B dot ds. B into surface area. Area, let it be A. This is NBA by I. Am I right? What is B? Mu naught H. Substituting. N mu naught HA by I. What is H for a solenoid? Ni by L. Or Ni by D. Substituting N into N, N square mu naught IA by D into I and I cancel. So inductance formula will become N square mu naught A by D. From there you got this formula. Is it clear? Okay. If you consider a cylinder, or we call it as a coaxial cable, For a coaxial cable, capacitance is 2 pi epsilon L by ln of B by A. And here for a cylinder, inductance is mu L by 2 pi into ln of B by A. Similarly, if you take a spherical capacitor, the capacitance is 4 pi epsilon by 1 by A minus 1 by B, where A is the radius of inner conductor and B is the radius of outer conductor. Similarly, if you consider a toroid, inductance is n square mu naught A by 2 pi r. 2 pi r is the circumference of the toroid. Toroid is like this. Similarly, if you consider an isolated sphere means outer sphere will go to infinity. As you know, inner sphere is having radius A, outer sphere is having radius B. Outer sphere is going to infinity means B is tending to infinity. Then this inner sphere is called isolated sphere, special case. For such isolated sphere, where B is tending to infinity, the capacitance of an isolated sphere is given by 4 pi epsilon by 1 by A, that is 4 pi epsilon A. Okay. Everyone, is it clear? Good. Try to solve this. A coaxial cable of inner radius 1 mm, A is 1 mm, B is 5 mm, has capacitance per unit length 172 picofarad per meter, let it be C1. If the outer radius to inner radius is doubled, means what is the present one? B by A, outer radius to inner radius 5 by 1, 5. Which doubled means 10. If this ratio is doubled, is asking find C2. You know, for a coaxial cable, capacitance is 2 pi epsilon L by ln of B by A. But L is on this side because it is farad per meter. This is C1, where you have B1, A1. Similarly, C2, 2 pi epsilon ln of B2 by A2. From this C2 by C1, it's 2 pi epsilon by ln of B2 by A2 by 2 pi epsilon by ln of B1 by A1. 2 pi epsilon and 2 pi epsilon get cancelled. ln of B1 by A1 by ln of B2 by A2. How much it is? C2 is C1 172 picofarad. 172 picofarad into ln of 5 by ln of 10. This will go down to 120 picofarad per meter. So your answer is the new capacitance is 120 picofarad per meter. Any doubts? Anyone? Any doubts? Let us solve this. The capacitance of an air-filled parallel plate capacitor is 60 picofarad. The capacitance of a air-filled parallel plate capacitor is 60 picofarad. The capacitance is given by epsilon naught A by D. So we can say what is given is epsilon naught A by D is 60 picofarad. Now what is saying? When the dielectric slab whose thickness is half the distance between the plates, you know, distance between the plates is D. Now I am considering half the distance between the plates is as a thickness. So what is the new capacitor? New capacitor is having half the distance, that means D by 2 as thickness. One of the plates are having a thickness which is equal to half the distance, means this is D by 2, this is D by 2. Now this is capacitance C1, this is capacitance C2. Very clearly both are in series. So equivalent capacitance is C1 C2 by C1 plus C2. How much is C1? Epsilon, the dielectric, A by D by 2. 2 epsilon naught epsilon r A by D. 2 epsilon r into epsilon naught A by D. But we know epsilon naught A by D is C, which is 60 picofarad. So 2 epsilon r into 60 picofarad. 120 epsilon r picofarad. That is C1. C2. C2 is this fellow. Epsilon naught A by distance D by 2. 2 epsilon naught A by D. You know epsilon naught A is 60. 2 into 60. 120 picofarad. Once you make these changes, the equivalent capacitance is given as 86 picofarad. That means what? 86 is equal to C1 120 epsilon r, C2 120 by C1 plus C2. 120 take common and cancel. 120 epsilon r by epsilon r plus 1 is 86. 86 epsilon r plus 86 is 120 epsilon r. 34 epsilon r is 86. Epsilon r is 86 by 34, 2.53. That's your answer. Any doubts, please let me know. Anyone, any doubt, please let me know. Any doubts? Please respond in the chat box. Shall we go for the next question? Next one. A capacitor of 3 microfarad is charged by a constant current of 2 microampere for 6 seconds. The voltage across the capacitor is dash. We know I is equal to C into dV by dt. I is 2 microampere, 2 into 10 power minus 6 ampere. Is capacitance 3 into 10 power minus 6 into dV by dt. Implies dV by dt is 2 by 3. Doing integration on both sides, integral of 1 dt. V is 2 by 3 t. But given t is 6 seconds, V is 2 by 3 into 6. V is 4 volts. So your answer is 4. Is that clear? We'll go for the next question. A point charge of 10 microcoulomb is placed at a distance of 5 centimeter from the center of a conducting sphere of radius 2 centimeter as shown in the figure, which is rounded. What is the total induced charge on the conducting surface? How much is the induced charge on the conducting surface? How do you find this? Induced charge. Capacitance C is equal to QV. Q, induced charge, is C into V. Very clearly, this Q is nothing but induced charge. Capacitance is an isolated sphere. So formula is 4 pi epsilon A. A is the radius. And V is the potential, which is Q by 4 pi epsilon naught R. 4 pi epsilon naught and 4 pi epsilon naught get cancelled. The induced charge is A, the radius of the sphere 2 centimeter. Q, the charge that is placed at 5 centimeter distance, which is 10 microcoulomb. R, distance from the sphere, the charge distance from the sphere, which is 5 centimeter. For Q in is A, Q by R. 2 into 10 power minus 2, 10 into 10 power minus 6, 5 into 10 power minus 2. This is 20 into 10 power minus 6 by 5. That is 4 into 10 power minus 6. Therefore, the induced charge is four microcoulomb. Out of 10 microcoulomb, how much charge is getting induced? The total amount of charge that is getting induced is 4 microcoulomb. Any doubts? Everyone, is it clear? Next one. The space between the plates of a parallel plate capacitor of capacitance C. So parallel plate capacitor capacitance is given as C. So C is epsilon naught A by D. Is filled with three dielectric slabs of identical size as shown in the figure. They are having dielectric constant epsilon 1, epsilon 2 and epsilon 3. What is the new capacitance? Please everyone do this. Tell me how they are connected, series or parallel? How they are connected, series or parallel? Clearly, these capacitors are in parallel. So, equivalent new capacitance is C1 plus C2 plus C3. How much is C1? Epsilon 1 area, 1/3 of it, A by 3 by D. This is epsilon naught, epsilon R1, A by 3D. This is epsilon naught A by D. Epsilon R1 by 3. This is C by 3 into epsilon R1. Similarly, C2, same case, epsilon 2 A by 3D. Same case, same analysis. C by 3 into epsilon R2. Similarly, C3, C by 3 into epsilon R3. Total capacitance, C by 3 into epsilon R1 plus epsilon R2 plus epsilon R3. Is that clear? Yeah, Aditi. Any doubts? Any doubts? Please let me know. We'll go for the next question. C naught is the capacitance of a parallel plate capacitor. This one. As shown in figure A, if half of the entire gap, as shown in figure B, is filled with the dielectric constant epsilon R, the expression for modified capacitance C nu. Now you tell me very clearly, here also we have two capacitors, C1, C2, how they are connected? How they are connected? C1 and C2 are connected in? They are connected in parallel, am I right? So what is C nu? C1 plus C2. How much is C1? Epsilon 1 area A by 2 by D. What is epsilon naught? Epsilon naught A by D. This is epsilon naught into epsilon R1 into A by 2D. This epsilon naught A by D is C. C by 2 into epsilon R1. Am I right? Similarly, what is C2? epsilon 2 a by 2 by d, epsilon 2 a by 2d. But what is epsilon 2? Epsilon naught. Epsilon naught a by 2d. C naught, let this be C naught. So this is C naught. C naught by, this is C naught by 2. So what is total capacitance now? C naught by 2 into 1 plus epsilon R1 or 1 plus epsilon R, whatever it is. C naught by 2 into 1 plus epsilon R. So option A is your answer. Is that clear? Just everyone let me know. Is that clear? Aditi, is it clear? Try and solve this. A parallel plate capacitor consisting of two dielectric materials is shown in the figure. The middle dielectric slab is placed symmetrically with respect to the plates, equal distance. If the potential difference between the one of the plates and the nearest surface of the dielectric interface is 2 volts, potential difference is 2 volts. Very clearly, here potential is 10, here it is grounded, means 0. And the difference between one and the other, the nearest one, is 2 volts. That means this must be 8 and this must be 2 volt. This must be 2 volt. So total potential is 10. Potential across the capacitor 2 is, potential across capacitor 2 is 8 minus 2. Potential difference 6 volt. Total potential V is 10 minus 0, 10 volts. So find the ratio of epsilon 1 by epsilon 2. Tell me dear, how to do this? How will you do this? How shall we do this? Potential across capacitor 2 is total potential opposite capacitance by total capacitance. You know, C1 is epsilon 1 A by D, because both are symmetric. C2 epsilon 2 A by D, same area, same distance. So substituting potential across capacitor 2 is total potential into epsilon 1 A by D by epsilon 1 A by D plus epsilon 2 A by D. Cancel out A by D on numerator and denominator. Total potential into epsilon 1 by epsilon 1 plus epsilon 2. So, voltage across capacitor 2 is total voltage epsilon 1 by epsilon 1 plus epsilon 2. We know voltage across capacitor 2 is 6 volts. It's 10 volt into epsilon 1 by epsilon 1 plus epsilon 2. 6 epsilon 1 plus 6 epsilon 2 is 10 epsilon 1. 6 epsilon 2 is 4 epsilon 1. Epsilon 1 by epsilon 2 is 6 by 4, which is 3 by 2. So the ratio is 3 by 2. The ratio is 3/2. Option C is the answer. Is it clear? Yeah. Everyone solve this. A soft iron is concentric with a long straight conductor carrying a DC current I. If the relative permeability mu r of the soft iron is 100, so what is given? The value of mu r is given equal to 100. The magnetic flux density at two adjacent points located just inside and just outside the toroid. If you consider a toroid, magnetic field point inside the toroid and outside the toroid, B1 by B2. We know for a toroid, magnetic field H is equal to Ni by 2 pi r. B is mu Ni by 2 pi r. Therefore, B1 inside the toroid is mu Ni by 2 pi r. B2 outside the toroid mu naught Ni by 2 pi r. I want B1 by B2 mu Ni by 2 pi r mu naught Ni by 2 pi r, which is mu by mu naught. We know mu is mu naught into mu r. From this mu r is mu by mu naught. You know mu r is 100. For this ratio B1 by B2 must be how much? 100. Clear? With this we have completed the last concept, that is capacitors and inductors. So what are the important concepts that we have studied here for your exam? Starting from the basics. In basics, I'll tell you some very important things that you must learn in basics. Addition of vectors, of course, by parallelogram law, and by head to tail rule. Head to tail rule is also called as triangular law. Then in basics, the important thing is multiplication of vectors by using dot product and cross product. 3. Vector identities. The most important of them Divergence of curl of any vector is 0. Curl of gradient of any scalar is 0. Fourth, point transformation. How to transform a point from one coordinate system to another coordinate system. Fifth, how to write differential length, differential surface, and differential volume, namely dl, ds, and dv in all the three coordinate systems, namely Cartesian, cylindrical, and spherical coordinate system. You must learn how to write dl, ds, dv in all these three coordinate systems. That is an important topic. Then you must know how to write divergence, curl, gradient, and Laplacian in all three coordinate systems. This is up to basics. Then once you go for electrostatics, the important topics are Coulomb's law, which gives you force between 2 point charges. Magnitude of force is q1 q2 by 4 pi epsilon naught r square. And you should derive the Coulomb's law. For line charge and surface charge. For line charge, look at electric field as 2 pi epsilon naught rho a rho. We have done sufficient number of problems also, both in the recording as well as in the live class. For surface, rho s by 2 epsilon naught an. Coulomb's law is a generalized law that governs electrostatics. The special law, can anyone tell me what is the special law here? Special law is the Gauss law, which can be applied only when you have Gaussian surfaces. What is a Gaussian surface? A Gaussian surface is one which is symmetric with respect to charge distribution. And according to Gauss law, the amount of flux cut by any closed surface is equal to the charge enclosed by the surface. This is called Gauss law in true form. If you expand this, you get Maxwell's first equation. Because we know that flux and flux density, how they are related, psi E is closed surface integral of d dot ds is charge enclosed volume integral of rho v dv. Applying divergence theorem, volume integral of del dot d dv is equal to volume integral of rho v dv. Del dot d is equal to rho v. This is integral form. This is point form. You must go through this Gauss law for sure. And applications of Gauss law, which are also equally important, you must go through point charge, line charge, surface charge, and volume charge. Then we'll go for conservative property of electric field. According to conservative property of electric field, the orientation of E is equal to 0. Electric field will always go in straight line. Closed integral of E dot dl is equal to 0, because when I close the loop, potential difference will become 0. This is called integral form of Maxwell's second equation. And this is differential form of Maxwell's second equation. Next important topic is electric potential. Which is a scalar quantity given by Q by 4 pi epsilon naught R. Relation between E and V. This E and V are related as V is minus integral E dot dl. E is equal to minus del V. This is the relation between E and V. And if you go for work done is half of volume integral d dot E dV, 1 by 2 volume integral epsilon naught E square dV, 1 by 2 volume integral d square by 2 epsilon naught of dV. How energy density is related to work done? Small w capital E is the derivative of work done. 1 by 2 d dot E, 1 by 2 epsilon naught d square by 2 epsilon naught. This is for electric field. Similarly, just like we have Coulomb's law for electric fields, and Coulomb's law also one very important point. Before you go for the exam, you must go through method of images topic for sure. Everyone must go through method of images. In magnetic field, just like you have Coulomb's law, which is the generalized law that governs electrostatics, for magnetostatics, you have Biot-Savart law. We have Biot-Savart law which governs magnetostatics. From Coulomb's law, we got electric field E is equal to Q by 4 pi epsilon naught R square AR, implying that electric field is always in radial direction. From Biot-Savart law, magnetic field is line integral of IDL cross R by 4 pi R cube. But you know, in magnetostatics, IDL is equal to all the differential current elements. IDL is equal to KDS is equal to JDV. Where I told you what is I? I is line current given in ampere. K is surface current given in ampere per meter, not meter square. Remember, and J is volume current, which is current density given in ampere per meter square. Therefore, the magnetic field intensity H will become line integral of ideal cross R by 4 pi r cube. Applying this equality here, surface integral of KDS cross R by 4 pi r cube, volume integral of JdV cross R by 4 pi r cube. From this, it is very clear that unlike electric field, magnetic field is not radial, but rather the direction of magnetic field is a resultant of current cross radial. But the resultant of any cross product is perpendicular to both the elements involving in the cross product. That means the direction of magnetic field will be perpendicular to both current and radial direction. Electric field is always radial, whereas magnetic field direction is perpendicular to both current direction and radial direction. Is that clear? Then when you apply it for a line current, the magnetic field intensity H is equal to I by 4 pi rho cos alpha 2 minus cos alpha 1 of A phi. This is for finite line. For a semi-infinite line, H is I by 4 pi rho A phi. It's for a semi-infinite line. For an infinite line, H is I by 2 pi rho A phi. And if you consider a finite line, at some radial distance, this formula will change to H is I by 4 pi rho cos alpha 1 plus cos alpha 2 of A phi. These are the formulas for the line current, the Biot-Savart law. Then we go for Ampere's law. According to Ampere's law, the line integral of tangential component of magnetic field intensity around a closed loop is equal to the current enclosed by the loop, where current enclosed is surface integral of J dot ds. Therefore, from this, closed integral of H dot dl is equal to surface integral of J dot ds. This is integral form. Integral form of Maxwell's third equation. Applying Stokes theorem on this, surface integral of del cross H dot ds is equal to surface integral of J dot ds. Implies del cross H is equal to J. Curl orientation of magnetic field intensity is not zero, because magnetic field will go in circular paths. That's why its orientation cannot be zero. Even the equation is telling the same. This is differential form or point form of Maxwell's third equation. Then we'll go for non-existence of magnetic monopole. That means a magnet always has two poles. A single pole cannot exist. That means it has two poles, north pole and south pole. And we know the magnetic flux lines will move from north pole to south pole. So outside the magnetic flux lines are moving from north pole to south pole. Inside the magnet, they move from south pole to north pole, forming the closed loops. Whereas electric flux lines, positive charge is the source and negative charge is the sink. We have separately source and sink in electric fields. In magnetic field, there will not be any source and sink because both the source and sink is the same, resulting in net flux. Psi m is 0 because this magnet is giving psi m and it is consuming psi m. Therefore, the net psi m is 0. And we know magnetic flux density B related to magnetic flux as magnetic flux per surface area is given by Weber per meter square or Tesla. From this, magnetic flux psi m is equal to surface integral of B dot ds. But you know that net flux is 0. Substituting closed surface integral of B dot ds is equal to 0. This is called the integral form of Maxwell fourth equation. If you apply divergence on this volume integral of del dot B dV is equal to 0. Implies del dot B is 0. Divergence of magnetic flux density is 0. Therefore, implying that B is divergence-less field. No divergence. Or it is also called B is solenoidal. This is the differential form of Maxwell fourth equation. So if you check out the table, for Maxwell equations for static fields, equation number integral form differential form and source. Equation 1 integral form closed surface integral d dot ds is equal to volume integral of rho v dv. Differential form del dot d is equal to rho v. Source Gauss law for electric fields. Second, closed loop integral E dot dl is 0. Differential form del cross E is 0. Static electric field is always conservative or it is irrotational field. This is from the conservative property of electric field. Third one, closed loop integral h dot dl is equal to surface integral of j dot ds. This implies del cross h is equal to j. This is from Ampere's law. Fourth, closed surface integral b dot ds is 0. Implies divergence of magnetic flux density is 0, or magnetic flux density is a solenoidal field. This is from non-existence of magnetic monopole. All these four equations are very, very important for your examination. One must go through these equations before you go for the exam. These are Maxwell equations for static fields. In time varying fields, equation 1 and equation 4 dot products will be same. Cross products equation 2 and equation 3 will change. This is changed by using Faraday's law. This is changed by using inconsistency of Ampere's law. If you include these two changes, then you'll get Maxwell equations for time varying fields. Equation number integral form differential form and source. Equation number 1, integral form, no change as I told you. Please repeat, closed surface integral of d dot ds is volume integral of rho v dv. Differential form, del dot d is rho v. Source, Gauss law for electric fields. Second, closed loop integral of E dot dl is surface integral of minus dou b by dou t dot ds. Differential form del cross E is equal to minus dou b by dou t. Now, del cross E is no more 0 because this is time varying field. Only static electric field is conservative, but not time varying electric field. This is from Faraday's law. Third, closed loop integral of h dot dl is surface integral of j plus jd dot ds. Differential form del cross h is equal to j plus jd, where j is conduction current density given by sigma e, jd is displacement current density given by dou d by dou t. This is from inconsistency of Ampere's law, or simply Maxwell contribution. The last one, as you know, closed loop integral B dot ds is 0. Del dot B is 0. Divergence of magnetic flux density is 0. Magnetic flux is divergence-less field or solenoidal field. This is from non-existence of magnetic monopole, or simply called as Gauss law for magnetic fields. These are Maxwell equations for time varying fields. Clear? So these are the important things that you need to learn for your exam. All the best for your exam, everyone. Thank you all for joining this session. Good night.